LangGraph's Pregel runtime orchestrates actor-channel interactions through a bulk-synchronous parallel model, where Pregel node instances process channel data in discrete execution steps. This artifact demonstrates a linear chain of two nodes connected via distinct channel types, showcasing how LastValue persistence contrasts with EphemeralValue transients in internode communication. We're about to examine how node builders configure subscription patterns and transformation logic, while the Pregel instance coordinates channel initialization and input-output routing. The code will reveal how string concatenation operations propagate through the channel topology, with each node's output becoming the next node's input.
From LangGraph, channels import LastValue, EphemeralValue. From LangGraph, Pregel import Pregel, node builder. Node 1. Node builder, subscribe only A. $x, x plus x. Write to B. Node 2. Node builder, subscribe only B. $x, x plus x. Write to C. App equals Pregel. Nodes node, node 1, node 2, node 2. Channels equals A. EphemeralValue ester. B. LastValue ester. C. EphemeralValue ester. Input channels equals A. Output channels equals B. C. App invoke A. Foo.
This example demonstrates a linear chain of two Pregel node instances, Node 1 and Node 2, connected through channels with different persistence behaviors. The architecture follows the bulk-synchronous parallel model, where each node processes data in discrete steps, reading from input channels and writing to output channels. The key mechanism here is the channel type selection. Channel A and C use EphemeralValue, meaning they only persist for the current execution step and don't retain history, while Channel B uses LastValue, which maintains the most recent value across steps. This creates an interesting behavior where intermediate results in B are preserved between node executions, while input and final output are transient. The data flows from input channel A through Node 1 to channel B, then through Node 2 to output channel C, with each node applying a simple string duplication transformation. The choice of LastValue for channel B enables stateful processing between nodes, which would be crucial in more complex scenarios where intermediate results need to be maintained across multiple execution steps. This pattern allows for building pipelines where certain transformations can access previous computations, while still maintaining clean input-output boundaries. The trade-off is that LastValue channels consume more memory than EphemeralValue channels, which might be a consideration in resource-constrained environments or when dealing with large data volumes. Let's break it down.
From LangGraph, channels import LastValue, EphemeralValue.
Imports two channel types from LangGraph. LastValue for storing the most recent value and EphemeralValue for temporary values that don't persist between steps.
From LangGraph, Pregel import Pregel, node builder.
Imports the Pregel class and node builder class from the LangGraph Pregel module, providing the core runtime components for managing LangGraph application execution through the Pregel algorithm model.
Node builder, subscribe only A.
Creates a node builder instance configured to subscribe only to channel A. This means the resulting node will receive updates exclusively from this channel without publishing to any channels itself. The subscribe-only method establishes a read-only relationship with the specified channel.
$x, x plus x.
Applies a lambda function that takes an input x and returns the sum of x with itself, effectively doubling the input value. This operation is chained using the do method, which executes the transformation on the data flowing through the channel or pipeline.
Write to B,
writes data to channel B in the current Pregel execution step. This operation sends the current value or update to the specified channel, making it available for other actors to read in subsequent steps. The exact data being written isn't visible in this segment, but the target channel is explicitly identified as B.
Node Builder. Subscribe only B.
Creates a Node Builder instance and configures it to only subscribe to channel B. This means the node will receive updates from channel B, but won't publish to any channels by default. The subscribe-only method restricts the node's channel interactions to read-only access for the specified channel.
Write to C.
Writes data to channel C in the current LangGraph execution context. This operation sends the current value to the specified channel, making it available for other actors to consume in subsequent processing steps. The exact data being written depends on the preceding operations in the chain, but this line specifically routes output to the channel named C.
App equals Pregel.
Creates a LangGraph application instance using the Pregel runtime, which will manage the execution of actors and channels in a bulk-synchronous parallel model. The app variable now holds this application instance, ready for further configuration of nodes and communication channels.
Nodes node. Node 1, node 2, node 2.
Creates a dictionary named nodes with two key value pairs, mapping the string node 1 to the variable node 1 and node 2 to the variable node 2. This establishes a lookup structure where node identifiers can be referenced by their string names.
EphemeralValue ester.
Declares a channel named with an ephemeral string value type. The EphemeralValue ester indicates this channel stores temporary string data that doesn't persist between execution steps, following LangGraph's channel pattern where each channel has a specific value type and update behavior.
B. LastValue ester.
Declares a channel named B that stores string values and uses LastValue as its update function. The channel will maintain the most recent string value received, discarding previous updates.
C. EphemeralValue ester.
Declares a channel named C with an ephemeral string value type. The EphemeralValue ester indicates this channel stores temporary string data that doesn't persist between execution steps, following LangGraph's channel pattern where each channel has a defined value type.
Input channels equals A.
Specifies that the actor or component will read from a single input channel named A. This parameter defines which channels the entity will consume data from during execution.
Output channels equals B. C.
Specifies that the output will be sent to channels named B and C. This defines the communication paths where the results of this operation will be available for other actors in the LangGraph application to consume.
App invoke A. Foo.
Invokes the LangGraph application with an input dictionary containing a single key, mapped to the string value foo. This triggers the application's execution with the provided input data, following the Pregel model where actors process the input through channels in synchronized steps. The specific behavior depends on how the application app is configured to handle this input. This implementation demonstrates how LangGraph's Pregel runtime orchestrates a linear processing pipeline through channel configuration and node behavior. The key insight lies in how channel persistence types create different data flow characteristics within the same execution model. Node 1 and Node 2 form a simple chain where each applies a string duplication transformation, but the critical distinction comes from channel B using LastValue persistence. This creates a stateful connection between nodes, where intermediate results are maintained across execution steps, while the input and final output channels use EphemeralValue for transient data. The Pregel instance coordinates this by initializing the channel topology and routing data through the specified input-output channels. The design choice between LastValue and EphemeralValue channels illustrates the trade-off between stateful processing capabilities and memory efficiency. Channel B acts as a persistent bridge between nodes, enabling more complex pipelines where intermediate computations can be referenced, while channels A and C maintain clean input-output boundaries. This pattern shows how LangGraph's channel system allows precise control over data persistence within the bulk-synchronous parallel execution model.
The channel swallows foofoo whole, leaving only silence where the node once shouted its X.